A potential bias that comes up often in the OT literature, especially in pilot studies, is multiple comparisons. Recall that a p-value is the probability that you made a type 1 error, and that a type 1 error is saying that a statistically significant difference exists when it really doesn't. If your p-value is 0.05, then you have a 5% chance of making a type 1 error. So, if you do enough statistical tests, eventually a type 1 error is guaranteed to occur. If the study performs multiple comparisons, what you want to see is something called a Bonferroni correction. A Bonferroni correction reduces the significance cutoff, alpha, based on the number of comparisons being made. For example, if 2 comparisons are being made, then alpha is divided by 2, and a result isn't considered statistically significant unless the p-value is less than 0.025. And if 5 comparisons are being made, then the p-value must be less than 0.01 to be considered statistically significant. Here is a results table from an AJOT paper by Maher and Mendonca. You can see they compared the scores of 6 different outcome measures taken before the intervention and after. To accommodate for multiple comparisons, they divided their alpha by 6 and set their significance level at 0.008. This means that the change in social relationships from pre-test to follow-up was statistically significant, but the change in mental health was not. A Bonferroni correction can also be used for post-hoc comparisons after an ANOVA. For example, the text accompanying this results table states, with a Bonferroni correction for 2 comparisons, p less than 0.025 was needed for significance.